A 10-kilometer long straight road connects two towns A and B. So there are two towns A and B, and there is a straight road connecting these towns. It's 10-kilometer long. Okay. Two cyclists start simultaneously, from one from town A and the other from town B. So one cyclist is going from town A to B, call it cyclist 1 supposed, and the other cyclist, call it cyclist 2, and the other cyclist is going from B to A. On reaching the opposite town, a cyclist immediately returns to his starting town, whereas the other cyclist takes some rest and then returns to his starting town. So one of these two cyclists, on reaching the other town, takes some rest and then comes back. Okay. Both of them can ride at a speed of 20 km per hour in absence of wind, but during their whole journey, uniform wind from A to B increases the speed of cyclists going from the wind by the same amount as it decreases the speed of cyclists going against the wind. So there is a wind from A to B. This is a wind, and let the speed of wind be W, and it is from A to B. So whichever cyclist is moving from A to B, wind will help that cyclist, and the other cyclist will be resisted by the wind. Both cyclists meet twice, first 2 km and then 6 km away from one of the towns. In which town and for what period of time a cyclist rests? Okay, so this is the question. Let the wind speed be W. Cyclist speed is given as 20. So the cyclist moving with wind will have its effective speed as 20 plus W, while the other cyclist will have effective speed 20 minus W. Cyclist 1 is moving with a larger speed, so it will cover a larger distance as compared to cyclist 2. So somewhere here, suppose these two cyclists meet like this, and it is given in the question they're meeting 2 km from one station. So it is obvious it is 2 km from B only, because from B the cyclist is moving with a slower speed. So from this information we can find the speed of wind first. Okay, let the time taken by both the cyclists to reach here is T. So then T can be written as, for cyclist 1 it is distance upon speed. This distance is 8 km because total is 10, and it's given 2 km from B then. So it will be 8 from A. So cyclist A is covering 8 km with a speed 20 plus W, and cyclist B is covering 2 km in same time with a speed 20 minus W. So we'll first solve this and get W. So let's solve it for W. Wind speed is coming out as 12 km per hour. Okay, so now we have known the wind speed. The same situation again. For cyclist 1 is covering this whole distance. This is for cyclist 1. So cyclist 1 will reach here at a time 10 km divided by 32. 32 is his speed, and then he is returning back, and it's given in the question that is returning for 6 km, and then they are meeting again. So the cyclist 1 will reach to this position after a total time equal to 10 by 32. This is the time when cyclist 1 reaches here, and to cover 6 km now, it will take a further time of 6 divided by 8. Why 8? Because while returning, cyclist 1 will now have a speed 8, because now he is moving against wind. For cyclist 2, for cyclist 2, so cyclist 2 is starting from this position from B. So it will reach A, and at A the cyclist 2 will be at a time 10 by 8 because 10 kilometers covered by a speed 8 kilometer per hour. And then the cyclist 2 will return by 4 kilometer. If this is 6 kilometer, this will be 4 kilometer. So the cyclist 2 will return 4 kilometer and reach to the same position. And now for cyclist 2, total time will be 10 by 8. And while returning for 4 kilometer, while returning, cyclist 2 will have now speed 32. So these are the two times, and call these times as T1 and T2. Now it is given that one of these two cyclists is resting for some time and they reach here at the same time. So first we'll see which one of these two times is less. Let's solve this. This is 32, 10 plus 24. So it is 34 by 20, 32. These many hours. While this is 32, 40 plus 4, 44 by 32. So now compare these two times. Cyclist 1 will reach earlier than cyclist 2 if no cyclist is resting. If no one is resting, then cyclist 1 will reach earlier. And since it is given that they are reaching at the same time, it is obvious that cyclist 1 is resting for some time, delta t. Call it delta t. Now, how much will this delta t? Delta t be of such a value that this total time will be equal to this time. So, equate these two times. So, 34 by 32, which we have already solved, this much is 34 by 32 plus delta t. This should be equal to 44 by 32. So, the resting time comes out equal to 44 minus 34 by 32 hours. That is 10 over 32 hours, and to convert into minutes, multiply by 60. And if you solve this, it will come out 18.75 minutes. So this is the time for which cyclist 1 will rest in town B. So cyclist 1 will rest in town B for this much of time. Okay.